The Edoardo Amaldi, in honour of the Italian physicist, is the third in the ATV programme. It follows the Jules Verne in 2008, which paved the way, proving the vehicle's advanced automated rendezvous and docking techniques, and the Johannes Kepler mission last year. Flying ATV-3 1 year later has been a major challenge. The Kepler flight evaluation had hardly ended, and the Edoardo Amaldi was already en route to be shipped to Kourou.
We are happy to say that, first of all, we didn't have to modify whatsoever from the previous two ATVs because everything worked perfectly. However, we have such a big and major added value in terms of increased cargo capability, and especially late cargo capability. For instance, we are going to load equipment that NASA needs to sustain the life of the crew on board the ISS.
Now that the shuttles are no longer flying, the Russian Progress, the Japanese HTV spacecraft, and particularly the ATV, have a crucial role in resupplying the International Space Station. New vehicles are planned, but the ATV will remain the most versatile of all these visitors, capable of taking the largest amount of dry cargo and fuels, and as an integral part of the orbital complex, responsible for maintaining its orbit and maneuvering to avoid space debris. Practically 6.5 tons has been loaded on the Edoardo Amaldi, 2.2 tons of dry cargo in its carrier racks, and in its reservoirs 280 kilos of water, 100 kilos of oxygen and air, 860 kilos of propellants to be transferred to the space station, and more than 3 tons to control the attitude and to reboost the orbital complex. The dry cargo includes clothing, spare parts, equipment, crew personal belongings, no doubt surprises from their families, and a few of the container bags loaded only a few days before launch will have fresh food.
Food is of course a nice thing to receive in the station, and especially fresh food. We have all kind of good food, very tasteful, but it's always nice to have real tomatoes, a real orange. So that's something we will look forward to.
ATV-3 will have 10 days after launch to rendezvous and dock with the International Space Station in a series of now familiar automated phases, but which this time will be monitored even more closely by teams at the ATV Control Center in Toulouse. This is because NASA has, for power and mechanical considerations, decided, unlike previous ATV arrivals, to keep the station's main solar arrays orientated at almost 90 degrees, facing the approaching ATV.
This orientation may, if not adequately counteracted, which we have studied the way to do, may induce sun reflection into our optical sensors that we use for docking, may generate spurious reflections of the GPS signal that we use for relative guidance, and may induce blockage of the communication between the ATV and the ground via the TDRS satellites.
The Edoardo Amaldi will remain attached to the ISS for almost 6 months, undocking late August. Hardly will it have burned up in the atmosphere that ATV-4, christened Albert Einstein, will be preparing for its own mission to service the ISS. When a rocket's fairing is gently lowered over a payload, this moment called encapsulation is always a moving one for the satellite teams. Even more so when it is a 17-meter tall Ariane fairing and when the spacecraft is as large and tall as Europe's automated transfer vehicle. Following the nominal schedule, this delicate operation took place on the 27th of February. It followed a few days after the last remaining items of dry cargo had been loaded into the ATV. The bridge and mechanical elevator apparatus fitted over the upright spacecraft already attached at the summit of Ariane 5 allows access to the pressurized cargo section of the ATV. It was first used on the ATV-2 mission last year when 29 bags were added. This time, 55 white bags were lowered through the 80-centimeter diameter docking hatch. The first item to be lowered into the Eduardo Amaldi was a large and hefty 60-kilogram piece of NASA life support equipment for the ISS. NASA did not have this wastewater and urine recycling unit ready for the main dry cargo loading which took place last November.
It's difficult to estimate the station needs so early on. So this late cargo loading gives us and NASA and all the partners for the space station much more flexibility in deciding what the station needs are and being able to load cargo as late as possible.
NASA's request to take this up to the ISS coincided with development that ESA had already initiated to improve this late loading capacity for the next ATV-4 and ATV-5 flights. ESA and the Swiss manufacturer of the lift assembly were thus able to adapt and check it out for use on the present mission. When the fairing was installed, all the teams thought it was their last opportunity to see the spacecraft. But a few days later, a redundant routine investigation evaluating photos taken after loading identified an issue on how 2 cargo bags were strapped inside the ATV. In this space business, no matter how late a problem arises, it is always better to be safe than sorry. The issue had to be addressed. And so a decision was taken to postpone the 9th of March launch to allow the fairing removal and the reinstallation of the late loading system. An operator was able to descend and check things out in the ATV's pressurized compartment to make sure that the flight and delivery to the ISS will be smooth and flawless.
Meanwhile, back here on Earth, while the crew stays busy aboard the space station, preparation and readiness continues at the Ariane Space Launch Site in Kourou, French Guiana, for tonight's launch of the European Space Agency's Ariane 5 rocket that will deliver the Eduardo Amaldi, that is the automated transfer vehicle 3 cargo ship carrying with it 7 tons of cargo for the crew. You're looking at a diagram of the automated transfer vehicle 3. That particular vehicle has 3 main sections of the spacecraft. It has a propulsion module that has 4 main engines and 20 smaller thrusters for attitude control. It also has an avionic module and an integrated cargo carrier. The avionic module is where most of the electronics that are required for the mission objectives are held, and also in the integrated cargo carrier, it is the portion that actually attaches directly to the ISS. The spacecraft will be docking to the aft port of the Russian Zvezda service module.
At the end of the Johannes Kepler mission on the 21st of June last year, the second of Europe's ATV unmanned space freighters had once again shown its excellence and record-breaking capabilities. But there was no respite for the program teams. Some grabbed a short holiday, whilst others, at EADS Astrium in Bremen, prepared to ship the next ATV to Kourou. an extremely tight schedule that has perhaps been the greatest challenge.
ATV stays about 6 months in orbit, and already during the 6 months you are doing a stepwise evaluation of that flight. The results from this flight evaluation have to be directly implemented in the next unit, which is already integrated on ground. So when we have finished the post-flight evaluation, there is only 1 month remaining before we ship the next one.
The Eduardo Amaldi arrived in Kourou at the end of last August and has since been assembled and tested before most of the cargo was loaded and the spacecraft fueled. Previous flights having been so successful, very few things have been changed. One of them, though, has been to optimize the spacecraft's protective shielding.
We have made the deeper calculations in terms of probability of impact with the debris or external bodies during the ATV lifetime in orbit, and these improved calculations have allowed us to reduce a little bit the thickness of this protective material in order to save about 45 kilograms of mass that we can use to load more cargo.
Dry cargo, water, gases and propellants, Eduardo Amaldi will be carrying very nearly 6.5 tons up to the ISS. The ability to load cargo through the docking hatch only a few days before the launch has also been improved. A heavy urine recycling unit will be taken up for NASA to the ISS astronauts.
They, of course, have their own stock of potable water that would have guaranteed anyway the survival of the crew for a very long time, but they preferred to have the new equipment loaded on ATV, and since the mass of this equipment is 75 kilograms, which exceeds what we were able to carry on the last late cargo, which was 30 kilograms, we had to develop, and we tested successfully recently, a new technology, a new type of operation.
After launch, the Eduardo Amaldi will have 10 days to rendezvous and then dock, automatically, but monitored by the ATV control center teams in Toulouse, liaising with colleagues in Houston and Moscow. Unlike for previous ATV visits, several ISS solar arrays will be deployed practically at right angles to the arriving vehicle. Ground controllers have trained how to cope with possible reflections that could interfere with the ATV's optical sensors and relative GPS. Compared to the two previous flights, there's a slightly greater risk of not being able to dock at the very first attempt. We haven't changed our procedures, it's just that the environment around the station will be a bit more difficult to manage. ESA's astronaut Andrei Kuipers and his Russian colleague Oleg Kononenko aboard the ISS have trained and will be ready to react in seconds.
We have to react in a short period to see if the ATV is approaching in the right way, because we have to, of course, protect both the ATV and the station, that nothing happens. And of course, like most of the training, you train for unlikely but dangerous situations.
Filled with waste cargo, the Eduardo Amaldi will plunge back to Earth in late August, disintegrating in the atmosphere. It will be just 3 months before European space ministers meet in Italy. On their agenda will be the future of the ATV program. After ATV 4 and 5, 2 follow-on scenarios have been explored, with ESA having a primary consideration to ensure that ATV investments, its advanced technologies and unique operational expertise are not lost.